Good day, good morning, good evening, wherever you are in the world. Welcome to another data analysis session brought to you by UrBizEdge. For today's session, we're having data ingestion series, and our special guest is Oladayo Siyanbola. So this program was brought together with the partnership between UrBizEdge and MHS Analytics. So for some of you that might be in Canada, might be interested in taking business data intelligence training, data analysis training, financial modeling, and also SQL for data analysis. Our partners, MHS Analytics, are based in Canada and they offer all of this training. And our motto is just basically they are committed to giving their clients the business intelligence edge they need using tools they already use, such as Excel, Power BI, and other data analysis tools. For us, UrBizEdge, we're a registered Microsoft Excel consulting, financial modeling, business intelligence, data analysis, and also enterprise solution firm in Nigeria. We specialize in helping companies and high-value professionals be on top of their business data. We're also the developer of some Microsoft tools, which you can also find in Microsoft Office Store, such as the Nigerian Finance Market Analysis tool. We're also a developer of the Nigerian Stock Analysis Dashboard, and so many other ones you can also find in the Microsoft Office Store. We're also a training company. We have branches in Lagos, Abuja, and Port Harcourt. So our next training, which will be on the 11th of April, that's Python for data analysis. On the 14th of April, we're having in-depth Excel training, executive dashboard, and also business data analysis. On the 17th of April, we're having financial modeling and financial planning training. That's what people want to take the AFM exams and some other financial certifications. So our special guest, Dayo. So Dayo is a data engineer enthusiast. He has proficiency in Excel, SQL, and also GCP, that's Google Cloud Platform Services. He has other interests in space such as augmented reality and also in space. So I'll stop sharing my screen. And with no further ado, I'll hand over the session to Dayo. So Dayo, over to you. And I'll go backstage now.
Okay, thanks, Dayo. Good afternoon, everyone. Let me just share my screen. I'm trying to start the PowerPoint presentation, so just give me a few minutes. Should have done that before. Okay, the entire screen. Okay, sorry, that was taking a while. Sorry, can you confirm that you see like a PowerPoint screen?
Yeah, I can see a PowerPoint presentation here.
Okay, let me just go into full screen mode. Okay. Good afternoon, everyone, and good morning for those in other places that it's morning at the moment. My presentation is on a data ingestion series, and my name is Oladayo Siyanbola. So this is the agenda. There's an introduction. I'll discuss the different approaches, and then I'll do a demo, and then there will be a conclusion. So introduction. So the data ingestion series is actually a 4-part series. I was reading a book, The Data Pipeline Pocket Reference by James Diamond, and I was reading the data ingestion part of that book, and I decided to write a 4-part series on it. And the book is actually interesting. So for anyone trying to start out in data engineering, you should actually read it. It's explain how to build data pipelines, how to do data quality checks, and how to monitor your data pipelines and the likes. And it's quite easy for like a beginner. So it's a book that I recommend for every beginner in data engineering. So in the first part of the series, I talked about what data ingestion is, and I demonstrated the full data ingestion approach with demonstration. In the second part, I talked about the incremental data ingestion, also with demonstration. And in the third part, I introduced what change data capture is, and I concluded with demonstrating how you can carry out your data ingestion using change data capture. Okay, so let's get into it. Introduction, data ingestion. So basically, in simple terms, what data ingestion means is you're moving data from a source to a destination. And if we look at that word, moving data, it connotes something like a pipeline, because a pipeline, like a pipeline of oil, means that you're moving oil from one location to another. That's what data ingestion means, except that in this point, we are moving data and not oil from a source to a destination. So what does it involve? That means you have to extract data from that source, and then you load that data into a destination. So you must have heard things like ETL and ELT. The E part of it is the extraction, and the L part of it is the loading. So when you look at the E and the L, what you're just talking about is the data ingestion. Then this is an example of that data pipeline. You have sources. Your source can be a flat files, like your CSV files, or relational database like your PostgreSQL or MySQL, or even APIs. You extract data from it into the pipeline, and it flows all the way into your destination, which most times are always a data warehouse, such as your BigQuery in GCP, or maybe Snowflake or Redshift in AWS. Now, you have the decision to make whether you want to carry out your transformation inside the data pipeline. That means you have an ETL design if you're carrying out your transformation between your extraction and your loading into the data warehouse. But you also have the option of carrying out your transformation after the data gets into the data warehouse. That means you have what we call an ELT pipeline design. There are different reasons why you want to choose ETL and why you want to choose ELT. Now, once you get your data into the destination, your analytics teams or machine learning teams now uses that data to answer business data needs, both descriptive and predictive. There is actually a move to actually ensure that the people that carry out this transformation are now the analytics team. So you now have roles like the analytics engineer role, which support the ELT. So what data engineers just do is that they extract and load the data, while the analysts just carry out the transformation, because they understand the questions that they need to the questions that they need to answer. So they carry out that transformation, and one of that tool that they could use to do the transformation inside the data warehouse is the DBT tool. So there is a move towards data engineers just doing the extraction and loading, while the analytics engineer carry out the transformation. But like I said, there are many reasons why you want to choose ETL versus ELT. Also, for that series, our source in that book was the relational database, and there are many ways you can develop your data pipeline. You could either write your custom code, like your custom Python code, or you could buy off-the-shelf tools to carry out your data ingestions. There are tools like Airbyte and Fivetran that you could actually pay, and then they help you to, instead of you writing your own custom Python code, you could use those tools to carry out your data ingestion. So the decision also still lies in the kind of company that you work for, whether they prefer to write their own custom Python code, or they have the money to be able to pay Airbyte or Fivetran to use their tool for the data ingestion. The data warehouse that was used in that book was Redshift, but I'm inclined towards GCP, so I'll be using BigQuery. Now, let's talk about the approach, the full data ingestion. So this is my sample table. This is a table I call order, and then we have two columns, order ID and order value, and we have the sample data here. Now, this is assuming this is our source. So let's assume that this is actually a table inside a PostgreSQL database. Now, if I have to move this data in this table to this place, which is my, assuming that this is my data warehouse, this is like a BigQuery data set. Now, I have to write a custom Python code. And what it does in the full data ingestion approach is that it reads this entire table and load it into the BigQuery data set, a table inside the BigQuery data set. Now, let's see what happens when it runs again. Oh, sorry. So when it runs again, this time around, we now have additional data in there. We have these two rows, row order ID 4 and 5 with this 400 and 500 values. Now, when the same Python code runs again, it reads this entire table all over. And then when it tries to load it into the BigQuery dataset, because there's another table there before, what it does is to replace that table with the new dataset that it has read from the source. So every time that it reads a table in the source system, it goes to the data warehouse and just replace that the target table in BigQuery. It replaces it. So that's how the full data ingestion works. So what that means is that I don't really have to worry about whether an update is carried out on the tables in the source system. I don't really have to worry about whether there is a delete operation carried out in the source system, because anytime my Python code runs, it reads this entire table. So it captures all the changes that have happened, and then it just goes into the data warehouse and replace that table. So that's how the full data ingestion works. Now, this approach is actually very simple. If you get your custom Python code right, it's very easy to implement. But the issue there is that it's less scalable for frequent changes to the source system tables. So what does that mean? Imagine you have a table that contains millions of rows of data. That means every time your Python code runs, it has to read over millions of data in that table every time. So consequently, what will happen is that your ingestion time to extract those data and load it into the data warehouse keeps on increasing. And it's not the best approach if you're having frequent changes to the source system. Like, for example, let's take for Uber that has maybe like a table where they takes the different orders that different users are ordering cab. Their data keeps on coming almost every seconds, and your full data ingestion is not able to capture that as it's happening. So it only captures it when it runs. But again, when you have millions of rows, the ingestion time takes a while because it keeps on increasing, because it has to read more data every time it runs. Now, the other approach is the incremental data ingestion. Now, this is the first instance of the Python code running. So we now have a new Python code for incremental data ingestion. Now, the first thing that I need to say here is that if you are going to use an incremental data ingestion approach, your table, when you're designing your table in the source system, whether it's a table behind maybe like an e-commerce website, you have to make provision for a timestamp. And what you can see, the difference between this table and the one in the full data ingestion is that there is a new column called an order timestamp. Now, what that order timestamp is the current time at which these data records are entered into the table. So by default, it will be the time that this, let's say the first row, which is 100 here, when it enters into this table, that current time will be our order timestamp. Then you move into the next one and move into the next one. So what then happens is this. For the first run of your Python code, it reads the entire table and then it loads it into a data warehouse. Now, what happens on the second run is this. Okay, another thing that I forgot to say is that during these your Python code runs, it also needs to capture the latest time in this other timestamp. And our latest time in this other timestamp will be this, which is 2023 04 09 0025 seconds. So it captures it and stores it in another table. You can decide whether to store it in your source system or your destination system. So you just need to store this latest time in a table, whether in the destination system or the source system. Now, let's see what happens when it runs the second time. Now, look at what has happened. We've had additional data records, which is order ID 4 and 5, and each of them has their own timestamp. So by the time this Python code runs, it won't read the entire table. It will only read the incremental row that has happened since the last run, which is order ID 4 and order ID 5. The way to do that is it's going to use the latest timestamp that was stored to filter out the timestamp that are higher than the latest one that was stored before. So what it will only capture is that it will only capture order ID 4 and 5, and it goes into the table in the destination system. And you now see that what it does is that it appends it to, so it's not replacing that table, it only appends these new records to the table in the data warehouse. So the advantage of this is that if I have a million records, I don't have to read a million record every time. So it has a better performance in terms of the ingestion time compared to the full data ingestion. So you don't have to read all the table every time. You only look for new updates that has happened in terms of the new rows that have been recorded in your table in the source system. So and then it reads it, and then it goes to append it to the table in the data warehouse. So that's how that works. Now, again, so this is what I meant, that if you have to use your incremental data ingestion, you have to design your specified table in the source system to have a timestamp column. You really need that timestamp column to be able to, at every time, look for new records that have been added to your table. Now, again, this is what I meant also, that the value in the timestamp column for each data record will be by default the timestamp at which the data record is added to the specified table in the source system. If an update is made to a data record in a specified table, the timestamp will be updated as well. Now, this is what I mean. Let's say we made a mistake that the order value for order ID 3 is like 400, and we make an update here. The time we are making this update, this other timestamp was to change to that current timestamp that we made the update. So when you carry out an update on your table, your other timestamp also changes to the new timestamp at which the update was made. Also, this is also the point that I made, that the latest timestamp in the timestamp column of the specified table in the data source, in the source system, needs to be stored in another table, whether in the source or destination system. The data stored in this table will be used in reading only the newly added incremental data records in the specified table in the source system. So now I've also talked about that, but one thing I forgot to mention is that in this second run of this Python code, our latest timestamp will now be this new one, this 2023 0409 000445. This will be our latest timestamp. And what the Python code does is that it goes to the table where we are storing it, where we are storing our latest timestamp, and go to replace this one with this, so that by the next time this Python code is running, it's only looking for the other timestamp that are higher than this one. So that was what that last point was trying to say. So, and then every subsequent run of the incremental ingestion scripts override this table. Yeah. Now, again, your incremental data ingestion is supposed to have better performance in terms of ingestion time when compared to with full data ingestion, but that only works with insert operation. So like I said, yes, it's supposed to have a better performance because you're not reading the entire table, you're only reading the incremental row records. but that only works with the insert operation. And insert operation is when you're inserting new records into your table in the source system. Now let's see what happens when you have to do an update and delete. Yeah, when you have to do an update and delete operations, then it introduces a whole new complexity where you have to do primary key matching between table in the source system and the table in the destination system, which in turn defeat the better performance expected. Let me try to explain what I mean by that. Now, let's look at this. Let's look at this table, this second table here and this second table here. This is our table in the source system and this is our table in the destination system. Let's say okay, so this is what I mean. Let's say we make an update to the order ID 3 and we change this to 600. Now, invariably, this my order timestamp also changes, right? And this now becomes my latest order timestamp. It will be higher than this 00000445. It will be higher. Now, when this Python code runs, it will capture this data because the order timestamp here is now the latest. So it will capture these records. But remember, we already have order ID 3 here. So if you go ahead to append it, what you have is that you have a duplicate of 3 in the destination system. So what the primary key matching means is that before you do anything in terms of loading this particular update to the destination system, you have to go back and read what you have in the destination system, this order ID. You have to go there and do a check to ensure that you don't have these 3, this order ID 3 there, but we have the order ID 3 there. So it looks at it and it sees that there is a duplicate that is going to happen. So what it will do is that it will go into, since it will see that there will be a duplicate, what it will do is that it will go ahead to delete this record and then it will now append the new one so that we don't have a duplicate here. So that's what I mean by a primary key matching. It will have to look at these primary keys here and try to check if the new data that you're trying to append as an order ID that is already in the data warehouse. Immediately it sees that, it will delete this off and then it will now insert or append the new one. So that's the primary key matching. So imagine if you now have 1,000,000 rows, you have to do that check for 1,000,000 primary keys, which is order ID. So you now see how it's defeating the whole purpose when you're doing an update operation. For the delete operation, it's also similar. Let's assume that I delete this row 3 here, and we already have the 3 here. We already have this order ID 3 here. Now, if I delete this and this Python code runs, it will capture this, that this 3 has been deleted. Actually, to capture that this 3 has been deleted, you won't see it there. But it won't delete this when it actually loads it into the data warehouse. The only way to know that this has been deleted is to read all the order ID here and check it against the order ID in the source, in the source system, and do a check. So when you see that there is actually an order ID in the data warehouse and it's not in the source system, that means we've actually deleted it. So it will go ahead and delete this also. So again, if you have a lot of records there, you're reading all of this and then you're doing a check to make sure that, okay, are they the same or has an update been made? So it now introduces a new complexity and then your data ingestion time keeps on increasing when you have to carry out that primary key matching. So yeah, so that's what I mean. Now, the last approach is the change data capture. But let me talk about something that we did in the full and incremental data ingestion. We had to write our custom Python script to enable that data ingestion to move data from the source to the destination. And if you have to deploy it in production, you deploy it to a function as a service. You have a Google Cloud function, or maybe your AWS, you could use AWS Lambda. And then you enable the cloud scheduler on top of the function so that it runs at a specified time. Or if you want to go into a little bit of complexity, you could use Airflow to orchestrate the whole workflow and specify the time that it should run also. So what that makes it is that it makes it a batch data ingestion. So what batch data ingestion means is that it's your script runs at specified times and then it goes and read, extract and load. Then maybe every 30 minutes it goes to extract and load. Every 30 minutes it goes to extract and load. So it happens at a specified intervals. Now, what if you don't have to write a custom Python code to enable that data ingestion? And also, what if it happens in real time? That's exactly where the change data capture comes in. Now, what is change data capture? So your change data capture captures events in your source system database. Event like whether you are inserting new records into your rows, whether you're updating, whether you are deleting, it captures everything. And then it uses a messaging system such as Kafka to stream these changes in real time. There are different messaging systems that you can use, but I think Kafka is the most common. But you could use a PubSub or I think AWS has, I think Kines or something also. So this is what it actually means. We have a PostgreSQL as our source, and then you have a Kafka in between, and then you have a Google BigQuery. So what happens is that with change data capture, it will capture all the changes that is happening in a certain database in your PostgreSQL, and your PostgreSQL will produce it as topics to Kafka, and your Google BigQuery will consume those messages from that topic into itself. So basically, that's what happens there. Your Kafka here enables the real-time ingestion to move from here to here and then to this place. So that's basically what happens in your change data capture. Like I said, this messaging system can be Kafka and it can be any other messaging system. Now, there are two types of change data capture. You have the log-based one. Now, in the log-based one, your change events are captured from the log. So if you're using MySQL, the changes will be captured from binary log. So you have to enable this binary log. And if you have a PostgreSQL, it will be captured from write ahead logging. So when you are using your relational database, they actually have a log and they are storing the changes that you're doing to your tables inside those logs. So for a log-based one, it actually just looks into those logs to capture those events. Then you also have a query-based change data capture. Now, the change events in the source system are actually captured from queries. So you need to specify what kind of queries do you want, whether it's a full one or an incremental one, and it execute those queries against your tables in the database. So this one actually do the actual SQL select star from. So you need to specify whether it's an incremental one or it's a full one in the query-based change data capture. Yes, so those are the different approaches. The only thing that I failed to mention here is that your change data capture is very good for a highly scalable system. Like it's very scalable, and top companies uses change data capture like Uber. I think also Airbnb uses change data capture to be able to capture their event and send it into the data warehouse. Now, because it's being captured in real time, that means wherever you're doing in the back end, whether it's your analytics that you're doing, you could also enable a real-time analytics because the data that you need are being sent to the data warehouse in real time. So most companies these days, if they have a system that data keeps on coming in every microseconds, they tend to go for the change data capture approach. And yeah, so that's actually much better than the full data ingestion or the incremental data ingestion. And you don't have to even write a Python or custom Python code to enable the ingestion. So that's the advantage that the change data capture has over the full and the incremental data ingestion. So this is the architecture of what I want to demo today. It's a change data capture approach. Now, what do we need? We need a Kafka cluster. And so we have a Kafka cluster here. We need a PostgreSQL, which will serve our source system. we need a Google BigQuery, which will serve as our destination system. Now, for you to be able to connect your Kafka to your PostgreSQL, you need what they call connector. And the connector that we are going to be making use of is a Ingestion PostgreSQL CD6 source connector. And we also need a connector from our Kafka to Google BigQuery, and we use a Google BigQuery sync connector. Now, everything inside this sort of rectangle, everything will be run inside a will be run in Docker containers, except the Google BigQuery, which will be outside. So that's the demo that I plan to show today. So I actually told Daya that after I get to this point, I will take questions. So if there are any questions, I'm ready to take them now.
Okay, awesome. This is looking interesting, actually. Okay, someone's asking, can you use Microsoft SSIS for data capturing? That's in Microsoft integration.
I don't have an idea. I've never used that tool before. But one thing I realized also is that some of the some of those other third-party tools that I talked about, like AirByte, also enables CDC, change data capture in them. So I won't be surprised if the tool you mentioned also has a change data capture as an integration inside them.
Okay, I think so. That's all the questions for now. So you can continue.
Okay, yeah, thank you. I see that time is going, so let me quickly just give me a minute. Okay, so sorry, can you guys see like a command prompt?
Yes. CD desktop, yeah.
Okay.
Directory.
Okay, thanks. Okay, I just wanted to be sure. So so inside my inside this directory demo, I have a Docker Compose file. I'll talk about it, but because time is fast running, let me just run the Docker Compose up -d. While it is running, I will show you what that Docker Compose file is. Okay, it's trying to create everything that I need there. Okay. Oh. Okay. Okay. Can you guys see my Docker desktop?
Yes.
Okay. Now, these are all the services that are inside the Docker Compose file. I have a PostgreSQL. Like I said, we need a source system, and this PostgreSQL is going to provide us with a source system that we need. Now, for you to be able to run your Kafka system, you need a Kafka cluster, and inside your Kafka cluster, you need a broker, which is just your Kafka server. You need your Zookeeper. It manages your Kafka environment for you, your Kafka cluster environment for you. Your schema registry just helps you to manage the structures of data that is being sent to your Kafka cluster and received or is being sent out, that is being sent to and it's being sent out. Yes, you need your connector. Your connector, I tried to show it in that demo architecture. You need your connector to be able to connect to the source system and to your destination system. Your control center, you don't really need it, but what your control center does for you is that it provides you with a good user interface to work with. So for a beginner like me also, I prefer to work with a good user interface compared to working with maybe your command line. Now, so all of them are running. It will take some time because some of the services depend on themselves, but I'll kickstart with the PostgreSQL source. These are stopped, but let me restart it again. So I'll kickstart with the PostgreSQL. Let's start with the PostgreSQL. So let me open another command prompt. Sorry. CD desktop. Actually, I have a Medium post that I'll probably share with you guys so that, you guys can, if you want to replicate this, you can actually replicate and follow along. So I'll share the links when I'm done. So now I need to, I've started up the Docker Compose files, all the services here, but I have the PostgreSQL source running. So the first thing I want to do is I actually want to start that container, like execute it. So I'll say Docker, no, it's here. Docker execute it. Name of the container, which is PostgreSQL source. PSQL, I think PSQL is just the PSQL. It's like a command line interface for your PostgreSQL in Docker. So -u is your user, which I named to be root, and then I will say source db. Okay, so right now we are now inside a Postgre SQL in our Docker, and our database is actually source.db. So one thing I failed to mention is this. If you give me a minute, let me show you what the Docker compose file actually looks like. So that it will look like I'm just writing all of this from thin air. Just give me a minute. Okay. I actually want to show you what the, so this is the Docker compose file that we actually ran. And let me try to, so this is what I actually wanted to show for you guys. So one of the containers that in that Docker compose file is the PostgreSQL source, and the image is actually PostgreSQL. So it's pulling this image from the Docker hub, and this is the name of the container again. Now the environment I said is root, the password is root, and the source DB is root, and this is the port, and this is just trying to set the write ahead login to be logical. So I said this set the write ahead login level to logical, which is needed to read the data from the logs. By default, it's always in replicable level. So this is just setting it to logical. So what you will see here is that I'm saying my username is root and my source DB is actually my database. So we've entered into the database. Now, the next thing I want to do is just create a table quickly. And so now I try to check whether there is a table in there. There is really no table. So what we do is that we'll create a table, create table orders, and we are going to 2 column order ID. I'll use a serial. I'll talk about what that serial is now. Primary key, and then the other one will be the other value. Let's name it that it's also integer, and then it's not null, so that means it's on, and the empty. So we've created a table. We have a table orders, and then we have other IDs. The serial here is like our auto increment in like my SQL. So that means if the default value starts from 1 and it keeps on incrementing by 1 for every subsequent rows, and you don't need to specify it, and it's our primary key. The other value is also of integer, and then it can't have an empty value. So we have that. Now the next thing I want to do is I want to insert values into it. So let's insert some values into others. Insert into others. Then since I said we don't, since this one is in zero, the only place that we need to insert value is inside the other value. So I'll say the values will be 100. Let me insert another 2 more. Other value, sorry, 200. Insert into others. other values, and then values 300. So now I've inserted 3 rows so we can check our table now, select star from others. So yeah, we now have our other ID, other value. So we've populate some data into this place. Now let me go back to my PostgreSQL here. So the next thing is I want to go into this control center and see what's happening there. So let me go into the control center. Yes, so this is what our control center looks like. It's showing us what the cluster looks like. We only have one brokers, and then I think there are a lot of default topics and there is production, consumption, just some data about the whole cluster. So I'll go into here, and we still have all of this, but the only thing I want to check here is I want to check topics. We have some default topics here, but we're not interested yet. Now we come to our connect, and this is our connect cluster, and we check here, and it's showing 0 connector, but let's add connects here. Now we have a Postgre connector here, which is what we need, and then we have a BigQuery sync connector. The reason why we have those two here is that if you look at my Docker Compose file, under the connect service, so this is the connect service. If you look at this point, these two places, I actually told it to go into the Confluence hub, and then it should go download the connectors that we need. So that's why you have those two there. If you don't include this inside your Docker Compose file, you're not going to see those two connectors there. So for whatever system that you're using, whether it's Redshift or you're using MySQL, you have to go into Confluence hub and try to get this link so that you can download it, and then you put it in your connect service so that it downloads it. So that's what has happened in our own case here. So what I would do now is that I would try to upload our connector configuration file. Now you need a connector configuration file, and this is for our source. I'll open it and try to just talk a little bit about them, but there are links where you can actually read it up. Now, your configuration file tells it how to connect to our PostgreSQL that we already started and insert some values there. And you need some information like your database name, which is source.db. Our database user and password is root. Our port is 5432. The host name is just what you named your service, which is PostgreSQL. These ones are by default. And then we have a topic prefix. I'll talk a little bit about the topic prefix after we upload this. So let me just close this and go back to this place. So I'll come into the Postgre connector here. Oh, sorry, made a mistake there. So I'll come to this place actually, and then I'll say I want to upload the connector configuration file. I'll come into my demo, and then I'll upload the source connector configuration file. So it just pre-populates all of this for me, and then I'll just say next. So it does a summary of it for me. We are using this connector. This is the name. You can name it anything. This is the server name. You can name it anything. And this is the topic previous. But what is most important here is that your database host name must be the name of your PostgreSQL source. Your name of the container that you're running this Postgre in, which I named PostgreSQL source. Your database port must be that 5432 that we indicated in the Docker Compose file. The database user and the database password must be what you said in your Docker Compose file, and then the database name, which is our source DB. This plugin name is also by default PG output, so I can launch this. So it's showing the status to fail, but just give it a few seconds and then it turns into running. So we now have our first connector that is running, and if I come to this place, this connector here is now running. So we've made a connection between PostgreSQL and our Kafka cluster, and everything is running in Docker container. So what's the next thing? We need to make a connection between our Kafka cluster here and then the Google BigQuery. So let me go into Google BigQuery. And there's something that we need to create before I upload that configuration file. Google BigQuery. Sorry, it's taking quite a while. Let me just go to our console. The dashboard, BigQuery. Okay, so I'm now in my Google BigQuery. This is my project name. So the first thing I want to do is just create a data set. Your data set in BigQuery is just like your database, your relational database. That's where your table resides. So I'm going to create a data set and I name it demo. So now I now have a demo. This is where my table will reside, but there's no table inside there for now. So now let's upload the next one, which is our sync configuration file. Now this is my sync configuration file. A lot of things are there, but because of time, I won't try to go through it. But you have what your topic is, you have what your the data set is, which is demo that I just created. I named the project in BigQuery. Some of them are by default. Some of them you have to actually put it the actual thing. So also you need a key file to be able to access it. But I think I might have made a mistake somewhere. I'm coming. Just give me a minute and let me look at the Docker Compose file. Oh no, no issue. So I did a volume mount. So that means the service account key that it's needed to be able to write into that particular project. I've already mounted it inside our connect container as key.json. Our service account key.json has been mounted into our Docker connect container. So because of time, let me just upload the other one and so that you can see what happens. So yeah, so I will come here and upload another configuration file, which is the sync. And then it pre-populates all of that for me also. And then we have all of this. But this is the most interesting thing here. The project is your it's your GCP project ID. Your default data set is demo, which I just created. Your key file is your service account key, which has been mounted, and then I just referenced it here. And this all of this. So I'll just say, okay, BigQuery, that takes a while also. And then now it's running. But let me come back to here. Now, we now have additional topic here, which is our PostgreSQL. One thing I failed to mention is that immediately I uploaded this source one, it already generated this PostgreSQL.public.orders for me as my topic name. Now, what you need to do is that when you're writing your sync connector configuration file, it will ask you for your topic, and that topic must be that particular topic that I just mentioned, which is PostgreSQL.public.orders. Why? Because your Postgre will be sending messages to that topic. You need your BigQuery to also read from that same topic. If it's not the same topic, it soon send messages to it. So that's one thing that you need to note, that it has to be consuming from the same where it's sending the message to. The topic that is sending the message to, your sync has to be consuming from that same topic. So we now have this, and then we can go to messages. But the first thing that I need to show you is go back to our BigQuery and reload it. So immediately our BigQuery start running, it does what our architecture now does for us, is that it sends all those initial data that we have in our PostgreSQL, it sends it into this place. So let me, now this time around, we have our data here. We now have a table here, we now have a table here called PostgreSQL public.orders. And if you look at the schema, these are all the columns that we have here. Now, the reason why we have all of these here is because we are using Debezium. So when you use your Debezium connector, it will not only send your messages, it also sends some additional data, like some metadata, alongside with it. All these are metadata: source, OP, TS, MS, transaction, and this other ID. But what you need here is that you need your before and after. And you could see that inside our before and after, we have an order ID and order value. So I will try to run a query so that we see what we have there. So I know I'm running short of time, but I'll try to finish like in the next 5 minutes. So it will come here, and then I'll just say before dot order ID. Then I'll run before dot order value. Then I'll run the after, and then I'll run the after dot order value. Sorry, oh shit. Oh no. Okay. So I'll run this. And if you can see here, I don't know if you guys can see the query result, but what we now have is in our before order ID
Yes.
and order value, we have null, null. But if you look at the after, we have the same values that we have in our PostgreSQL, 1, 2, 3, and then 100, 200, 300. So you have to look at your after value. What the Bizum does is that it keeps a before and after state. If I make an update to maybe 1, it moves this initial value to the before, and then the new update will be after. So what the Bizum helps you to do is that it keeps a before and after value. So basically that's what happens there, and that's why it's keeping it before and after. Your before are always null at the beginning, but you always need to just look at your after. Those are things that you just need to look at. So that's the Bizum for you. I really don't like how it comes like this, because it not only shows you what you need, it shows you more. Like it shows you all those other metadata, but we've already have the data here. And what has happened is that it does an initial snapshot and just sends all the data from PostgreSQL to BigQuery. Now let's see when we need to carry out an update. So I'll go back into my PostgreSQL here, and then let's insert just one more values. But I need you to actually look at what's happening here. Look at this message area here. You actually see a topic that is being produced. Immediately I insert a new value. So insert into others, other value, then values 400. So now I've inserted another value here. Okay, I don't know if anybody see it. Now look at what we have here. Inside our messages in our topic, this is actually the message that is being sent to the topic. So this is it. It just tells you what your before is, null, and then your order ID, and then your order value. So if you go back into our BigQuery again and try to run it again, we should have our values there. Okay, sorry, let me just refresh it. Sorry. Sometimes you just need to do the refresh, but the values will be there. Sorry, where's the refresh? Sorry, let me just reload it. Sorry, I made a mistake. Okay, so now let me run it again. So you can see now that we have our new data there, which is 400 also here. The next thing that I just want to show is I want to carry out a delete and update stuff here. But because I need to do an update and delete, and I need it to reflect in the before and after. I mean, I could easily do it, but then there's another syntax that you just need to enter. You need to change. You need to carry out a replica full in your table here, and I'll just quickly do that, and then we'll alter something. Okay, now I'll carry out an update for 300. We'll just change it, the value. So update update orders where no set set order value to be 600, where order ID equals to 3. So it has made that update, and then I'll do another one, which is delete from orders where order ID equals to 1. So let me show you what we have in our table now. Select from orders. So we've been able to delete the order ID 1, and then we've been able to change our order ID 3 from 300, the value from 300 to 600. So now let's see what has happened in our BigQuery. Okay, now let me run it again. Okay, so now you something is wrong somewhere, but I'll try to figure out what went wrong. Okay, if you look at this, for 300, it has now moved our before value, which is 300 to the before part of our schema here, which is the order ID and other value, which are the before, and then our new one now has a 3 and 600. So like I said, you only have to focus more on the after. You really don't have to focus more on the before, but it keeps a before for you. So you still have our 100, so I have to assume that it doesn't really send that, it doesn't really consume that message. So let me see again. Okay, let me run it again. And if you look at it now, we don't have 1 again. It has deleted 1 from the records. So basically, that's how you carry out your change data capture. It's everything happens in milliseconds, and you can carry out your insert operation. You can carry out your delete, and then you can carry out your update. And like I said, big companies uses something like this, and because they need to make decisions in near real time. So if you want to move to near real time, change data capture is something that you can use. So one of the UKs of change data capture is data ingestion, but you could also use it for data replication. So if you have your data in MySQL and you want to also have it in your PostgreSQL, you can be streaming those data. If MySQL is your primary data relational database, you can be streaming from your MySQL into your PostgreSQL. So that's another thing that you can be using it for. So basically, that's the demo that I have. I know I rushed through it, but I could actually share my Medium screen with you guys. So
Yeah.
sorry, Medium links with you guys, so that you guys can actually read a little bit more and understand it better. So so yeah, thank you so much.
Awesome.
This is my socials. My LinkedIn is
Okay.
GitHub
Okay,
is
I
Medium is
won't drop your LinkedIn now. So for some of you that might have questions for Dio, so I'll drop his LinkedIn in the chat box. Also, Dio, can you share the Medium post, or shall I also get it for you?
Okay, so I'll share the Medium post now.
Okay, awesome,
Don't worry, I'll share it. Let me stop sharing.
Awesome. Interesting. Okay, I can see David says that you didn't add timestamp. Timestamp is not included.
So for your Debizium, you don't really need a timestamp. But again, one thing I failed to mention is that it's not only Debizium that you can use as your connector. There are other connectors like JDBC. Those ones actually use a query based, not the log based. So if you're using a JDBC and you want to use increasing as your mode of trying to extract data, you need to specify a timestamp in your source tables. Yeah, but for Debezium, you don't really need a timestamp.
Okay. Okay. Awesome. So if you have any question for our special guest, please you can raise your hands up so I can make you a speaker, or you can drop your question in the chat box. So as we're waiting for that, okay, I have a very silly question though, but let me just ask. Are you ready?
Yes.
Okay, so in terms of the change data this thing, right? What about it? Can you do something such a way that you can add like a trigger whenever the data source is changes, like the whole pipeline activates, like the whole orchestration activates? Is it possible?
So this doesn't necessarily, for your change data capture, you don't necessarily need a trigger.
Okay.
So yeah, because it's the way I'll say it is that it keeps on. There's something that they call, there are two ways for you to know whether something is changing. It's either you're pulling it or you're using trigger. So what this does is pulling, and it does it in milliseconds, like 10,000 milliseconds. So it goes to pulls it every milliseconds, but it's enabled by your engine that you're using, your messaging system that you're using, whether it's Kafka or others. So you don't really need a trigger in this point, in this case. But I also understand that if you're using maybe a function as a service, you might want to put a trigger there so that you can capture it as its outputs also. But for this particular change data capture, you don't need a trigger.
Okay, thank you. At least you cleared. I was thinking about something. Okay, awesome. So since no question is coming, so the last two questions, which I said I was going to ask you at the end of the session, is the first question: how you started your old data journey? That's your old data engineering journey, and also what advice you have for people just starting out in the field of data engineering?
So thanks for the question. How did I start? Okay, so my background is in petroleum engineering, and I used to work as a petroleum engineer. So the need to actually automate things was what got me into data engineering. And so we used to have a lot of data that comes from our oil feed, and we used to do some things manually, our analysis manually and all. So the need to actually build something that it's automated, and then we can actually see things as it happens, and being proactive instead of being reactive was actually what got me into data engineering. So I started learning SQL and Python and started trying to use it to build pipelines of data. And then I also knew that for me to be able to automate it and share with others, I need to learn a little bit about computing and storage on GCP or maybe other cloud platforms to be able to host or to be able to deploy your functions and or your scripts that is like. So that was what actually got me into data engineering. In terms of advice for people trying to get into data engineering, I'm still trying to get into data engineering, and this would be a shameless plug. If you guys have like an internship or wherever in your place, I'm actually interested to intern or maybe an entry level. Yeah, but if you want to get into data engineering, start from the very basic, like SQL, learn your SQL, learn your Python. Start looking at things that you could actually try to use Python to automate. There are a lot of tools out there, but if you get with the basics of SQL and Python, you can really do your data pipelines with. You can build your data pipelines with Python. You could do your data cleaning with Python, SQL. You could start moving data from a database into a data warehouse and learn a little bit of the cloud. I will actually advise for a beginner to actually start with GCP. I always feel like GCP is very easy to understand as a beginner before you move into maybe AWS. So start with GCP, start playing with things like cloud storage, BigQuery, start writing your queries in BigQueries and the likes. Yeah, and then start looking for how you can build some little projects for a start. So that would be my advice for someone that wants to get into data engineering.
Okay, awesome. So I guess no other question again. Is there another question before we close? And also, I made mention the recording for this session we made available on our YouTube channel at least before the end of tomorrow or max Tuesday should be made available. And also, we're having another section by 6, which is text manipulation and data cleaning. So I've dropped the link in the chat box for some of you that might be interested. So I'll say Dayo, thanks again for honoring our invitation. Thank you so much. Shall I say happy Easter to everyone? And bye, guys. I'll stop recording. I'll say bye to everyone. Do have a lovely week ahead. So bye, guys.